Hi folks, my name's Jerome and I'm a technical marketing engineer here today to discuss SD-Access for the trusted workplace. We will be briefly recapping on Fabric components for those that aren't familiar with the latest in SD-Access, and then we'll be moving into the main content of the presentation, which is Fabric site deployment patterns, how we interconnect sites and extend segmentation, and then I'll put it together with a demonstration. So I'm hoping that by the end of this talk, you'll be clear on SD-Access as a tool to meet a range of customer use cases, deployment scenarios, and migration requirements. We'll be focusing on the yellow box here. So just more broadly, this is a blueprint for our SD-Access for the workplace model. But specifically today, we're zooming into SD-Access Fabric, which is a Lisp VXLAN based fabric for delivering macro segmentation, both in L2 and L3. And we'll be looking at micro segmentation using Cisco's scalable group tags, which are tags that are attributed to traffic as it moves in and out of the network. And we apply policy based on those tags, like permit printers to servers or block BMS devices to BMS devices or whatever it might be. Just a quick recap on Fabric components for those that may not know. I've broken this slide up into two parts. The first is mandatory components, and as you'll see in a second, the next part is optional. So as I mentioned, it is a Lisp VXLAN based fabric, meaning that we use a VXLAN to deliver L2 and L3 overlays for macro segmentation, and we use Lisp as a control plane to track where endpoints are connected. So with that, the main components are DNA Center, where we input our business intent, and that's translated into configuration and deployed to Fabric nodes. There is the Fabric border, which is what route peers with the outside world. So does that VXLAN to outside world translation? Maybe. We'll see some permutations of that later on. We have Fabric edge nodes where wired endpoints are connected in, and there's also a wireless integration we'll see in a moment. And then, as I mentioned, there's control plane node for tracking where endpoints are connected and taking care of mobility events in wired and wireless. Optional components are Identity Services Engine. So that's our NAC and policy distribution system. Previously, it was mandatory, and it's been changed to optional to accommodate some of the new use cases we'll be discussing for SD-Access. Most specifically, it would be SD-Access at the distribution layer, where endpoints aren't necessarily connecting into Fabric, they might be connecting into something else. So in that case, obviously, ISE is not necessarily required in that scenario because there's no authentication and authorization of endpoints. It would be recommended, though, for an SD-Access to the edge implementation, of course. Fabric wireless controllers and APs. So our wireless solution can integrate into SD-Access Fabric. So that means it has a unified data and policy plane. So meaning APs will VXLAN traffic into the Fabric edge, and they'll drop into their respective virtual networks based on radius attributes. So there's a distributed data plane there, meaning we can get some pretty high aggregate bandwidths, obviously, because the edge switches are taking care of wireless decap and routing. And it also means it's a unified policy plane, so it's the same SGT between wired and wireless. So we can apply the same micro-segmentation policy to both systems. There is extended node. We'll get into that a little bit later, but for now we'd say it's a layer 2 switch that extends Fabric, and I'll explain why in a couple of slides. And then there's intermediate node, which is also optional. So intermediate node is really just a big L3 switch that moves Lisp and VXLAN between Fabric components. So you can have 0 intermediate nodes, or you can have 2 or 10. It doesn't really matter. As we can see here, Fabric is topology agnostic. So I've deliberately connected one Fabric edge to another just to prove the point that as long as there's /32 reachability between components, it doesn't really matter so much what's in the middle. Okay. Just in service of this message of flexibility, those roles that I mentioned can be co-located or disaggregated based on requirements. So for a large-scale Fabric, we might have a dedicated border and a dedicated control plane node, but obviously for a branch, that doesn't necessarily make sense. So we can co-locate, for example, border node, control plane, Fabric edge, and wireless LAN controller in a 24-port 1RU switch. Obviously, that would be appropriate for 10, 50, or 100 endpoints or something like that, but it wouldn't be appropriate for 50 or 100,000 endpoints. So we choose co-location based on requirements and scale. The bottom one here are SD-WAN and SD-Access co-located in the same device. We'll zoom in on that in a minute when I talk about how we interconnect fabric sites. Okay, so our gold standard fabric site deployment pattern would be SD-Access to the wired and wireless edge. This is something that we've been discussing with customers in the field for a few years now. So this is SD-Access right to the edge of the campus, which gives us a number of benefits like topology agnostic L2 and L3 VNs. Again, because it's overlays and a list-based control plane, what that really means is any VN can be anywhere and any IP address can be anywhere within the fabric. We have macro segmentation, obviously, and micro segmentation through VNs and SGTs. This is all automated with, as I mentioned before, that unified wired and wireless data and policy plane. So this is a reasonably well understood deployment pattern, and now I'm going to zoom into some new ones just so we're clear on what it is we've been announcing the last few weeks. Okay, so the first one would be L2 access. In this scenario, what I have is a fabric edge. As I mentioned before, it instantiates the L2 and L3 VNs and all the default gateways for those VNs. On the left-hand side, we have a traditional switching domain, so that might be CLI configured Cisco switches or other vendor switches, and those switches can trunk into a fabric edge, handing off obviously VLANs, which can then terminate into L2 and L3 VNs. What this means ultimately is that if we have numerous fabric edges with L2 domains connected into them, fabric can function as a bridge, either an L2 or an L3 bridge between these different non-SD-Access domains. So that's what's happening on the left there. The AP with the dashed red line represents VXLAN. As I mentioned before, the APs, if they're fabric APs, integrate into the fabric data plane and policy plane. On the right-hand side, there's policy extended nodes. So those would be specific Cisco switches that aren't Lisp VXLAN capable, but bring some other attributes like tolerance for temperature, dust, humidity, and that sort of thing. So these might be our industrial Ethernet switches, as an example. And the little tag there represents that they are SGT aware and capable. So we can accomplish that micro segmentation and macro segmentation down to factory floor or roadside or some sort of hostile environment. Okay. The next use case that's been cropping up a bit recently is fabric over a traditional IP core. So as I mentioned before, intermediate nodes are just big switches. And what this really means is that if a customer has a campus, and I've certainly worked with some in this scenario, they might have an IGP already deployed, and we can just attach fabric elements to the edge of that IGP and use the existing core as a transit between fabric nodes. So what this brings immediately is macro segmentation and micro segmentation without having to change the original core. So there's no changes necessary to be MPLS aware or SGT aware because VNs and SGTs are tunneled and VXLAN overlay over a traditional IP core. So it's an easy way to get started with just a few nodes attached to the edge of an existing network. Okay. And the last one I'll touch on briefly is multi-site remote border, and this really represents VN anchoring. So this is something else we've launched in the last few months, where an existing border, rather a particular VN can be pinned to a border in a location. So as an example, we might have a guest network where we want traffic to egress at a particular place. So we can pin a guest network, say, to a DMZ border, while other networks or other VNs will hand off locally on local site borders to access local assets like internet, data center, WAN links, that sort of thing. Okay. We're then going to zoom into how we extend segmentation between sites. There's three major methods. The first is the method that we've had for since day zero, which is just standard IP handoff, where a border node will route peer per VN or per VRF to an external entity, and that external entity needs to take care of routing table segmentation to somewhere else, and potentially SGT propagation depending on hardware and software. Data plane, Ethernet, SGT is a little tricky to move from one place to another. It's very dependent on what's actually doing the forwarding in the data plane. The second is SD-Access as a transit. So in this case, the borders essentially exchange reachability information with the control plane, and When there's traffic moving from one fabric site to another, obviously a border will do a lookup, realize that it's in a different fabric site, and VXLAN tunnel traffic between SD-Access fabric sites. So this is basically SD-Access between SD-Access, again giving us our VN and SGT preservation. It's also reasonably easy to bring up. It's quite a straightforward exercise in DNA Center, and we'll see that in the demonstration. And then the final way of interconnecting segmentation or extending segmentation is our co-located SD-WAN and SD-Access. In this particular case, what we see on the left-hand side here, the shield with the BNCP, that represents a SD-WAN edge node. There's also an SD-Access border and control plane. So in this case, we integrate the two controllers together, DNA Center and vManage, and it will take care of that automated stitching of SD-Access virtual networks into SD-WAN VPNs. So it gives us an end-to-end routing table segmentation again, and also the SGTs are propagated throughout those SD-WAN VPNs, so we can get our end-to-end micro-segmentation, as well as the benefits of SD-WAN, obviously, cryptography, path-aware steering, local internet, that sort of thing.
Yeah, so as I'm looking at this architecture, would you say this joining of Lisp and VXLAN would be a complementary technology to something like EVPN multi-site, where you're trying to separate fabrics that way, and carry something like type 5 routes for multi-tenancy, or is this something that you would replace with multi-site as you're trying to preserve that segmentation and that multi-tenancy there, and the way that you're outlining that? I'm just trying to better understand how that fits.
Yeah, sure. Look, I certainly don't consider myself to be an EVPN expert at all. I'd be a novice at best. So as far as SD-Access Transit is concerned, this is all bundled into DNA Center, and we'll see this in the demo where I'll stitch up some sites using SD-Access Transit. So it's definitely a one-stop shop in terms of extending that segmentation. If it was EVPN, obviously we'd need to put something in the middle and manually stitch that in today. Could we put EVPN between fabric sites? I've actually seen some very rough models of that. I've never really seen it get up. I can't say why one would be. Well, I can't say why EVPN might be better. All I can say is that the SD-Access Transits definitely appears to be working as spec. I don't know if that helps answer or not.
Yeah, I was just trying to understand if it's an either-or thing or if they're complementary. Because in a lot of data centers, when you're getting away, I know this isn't the data center use case, but It's the same kind of fundamental problem of separating fabrics. That's why I was curious.
Yeah, we did have a little experimentation with EVPN between SD-Access and the data center, so our ACI solution. That ran into a few challenges with respect to permutations of deployment scenarios. So that's been parked for now. Okay, moving on. As far as extending identity context to other places goes, we do have two protocols, SXP and PXGrid. They do different things, but for the sake of this conversation, which is focused specifically on SD-Access and extending segmentation data, we can think of them as roughly the same thing. What this means is we have ISE that runs both PXGrid and SXP. These are open standard protocols. ICE can then share SGT and relational data with other systems. So it works with our firewalls, FTD and ASA. It also works with a number of other vendor firewalls if they've built that protocol stack into their implementation. There is an integration between ISE and ACI. So APIC specifically is the controller in our fabric-based data center. And there's an SGT EPG exchange between those things. EPG is the ACI version of microsegmentation. And ultimately what that means is there can be an end-to-end policy that refers to SGTs and EPGs in either of these domains. And then there's SXP also for reattributing SGT data to traffic as it may traverse a domain that's not SGT capable. So what we see here is this yellow line represents a forwarding path that doesn't have SGT abilities and it's not running SD-WAN or SD-Access Transit. In this case, SGT is removed and re-added by the bottom node based on the data download from ICE. There's also other places that this information can be shared. So the Secure Web Appliance, StealthWatch, and DNA Center uses PXGrid to download information about endpoints too. Okay, so that was a brief flyby of some of the new deployment scenarios, deployment models, and microsegmentation extension models. So what we're going to zoom in now to is a demonstration where I have two fabric sites. On the right-hand side, there's SD-Access to the wired and wireless edge, and I'm going to extend as an exercise SD-Access to the left-hand side. So we want to extend our micro and macro segmentation from this east site, which is an existing site, to the west site on the left-hand side. As we can see on the right-hand side, there's two endpoints. They're each authorized into different virtual networks, IoT-VN and Corp-VN, and they each have a tag assigned based on the logic inside of ICE. So one has a BMS tag and the other has an employee tag. We're also going to convert the wireless on the left-hand side to fabric wireless. So the assumption is this existing AP is a reasonably modern Cisco AP that is SD-Access capable. If it was an older one, it may need to be replaced, or it may need to use a different means of connecting into fabric. What we can also see on the left-hand side is there's two SVIs, a 1010 and 1020. Those are both in global routing table, which means there's no macro segmentation at this point. So these two endpoints can see each other unless we're manually deploying ACLs or port security or something like that. So how we're going to accomplish this is to swap out on the left-hand side that existing distribution switch for an SD-Access fabric in a box. Here, it's appropriate to use all of these co-located roles because it's not a large-scale site. It's a branch with a few switches. We'll also move those SVIs, that 1010 and 1020 SVIs, into SD-Access virtual networks. So by virtue of doing that, obviously we're implementing macro segmentation, which is routing table separation, and then we'll put in an SD-Access transit between these two sites to extend those virtual networks and the group tags for microsegmentation to the east side. The AP will be moved into VLAN 999, which is where the wireless LAN controller will exist inside of that switch. So by virtue of that, the AP joins the fabric WLC and becomes fabric capable. Making sense? Okay. If there's no questions, we'll jump into the demo. Okay. So if we hop into DNA Center, I hope the font size is okay. I can probably zoom in a bit if there's a problem with it.
I do have one quick question for you about the group tags.
Yeah.
Where do those live in the header? Where do those live in the header of a packet? Is that a Lisp framework?
Yeah, it depends on what the transport mechanism is. So inside of VXLAN, it's VXLAN GPO. Inside of Ethernet, it's quite literally a header between Ethernet and IP. Inside of IPsec, it's encrypted into IPsec. In GRE, it's its own header. So it depends on the transport mechanism.
Okay.
Cool. Maybe we can't go into roadmap. I've certainly been told that, but there is actually some work happening to potentially embed SGTs into Lisp as well. It gives us a way to signal source dest SGT at ingress rather than tunneling traffic to somewhere else and then making a decision at egress. But that's a roadmap thing we probably can't go too much into. Okay. So if we have a look at our fabric, what I have here, as I mentioned, is that east site, which is the already deployed headquarters type thing. So we've got two borders, two control planes, fabric edges, and some fabric APs, and a wireless LAN controller that is in the data center. And then if we have a look at our west site, right now there is a fabric in a box here. This fabric in a box, well, currently it has no actual roles provisioned to it, so it's just a Cisco switch. And if we just jump across, I did this last night because this is a 10-minute process in its own right that you don't want to watch. But I did factory reset this switch and reload it, and basically what's happened is it boots up, it finds DNA Center through some DHCP options in this case, and then we start plug and play, and basically it's grabbed by DNA Center and onboarded. So this is a factory default switch that I've just dropped in last night, and now that it's in inventory, we're okay to provision our fabric roles. So I'll put on border, edge, control plane, and wireless LAN controller. And then for the wireless LAN controller, we want it to be the WLC for both floors in this hypothetical west site. we'll go ahead and deploy that. So DNA Center will take care of provisioning those roles to that device. And now we'll go ahead and move our SVIs into this new device. Okay, so while that's happening, we'll go to Virtual Networks, IP Pools, and let some gateways. And what's happening here is we're going to add a gateway to Corp VN for our corporate macro segmentation, Infra VN for our AP, and IoT VN for our BMS device. This change we'll be doing at the west site specifically. So for each of these, I'll add a pool. If you remember the numbers, corporate was 1020. So I'll just shorthand a name here so you don't have to watch me type. I'll call the VLAN name corporate VLAN, VLAN ID 20. In this case, traffic type is data. Default SGT is employees. So what this means is if ICE is not assigning an SGT to the endpoint when it connects in, which obviously it's not in the model I showed because those gray switches are not SD-Access switches. What this means is a default SGT will be assigned if there is not a dynamic SGT assigned. We'll make this a wireless capable network as well, so it means it's extended over the fabric wireless. Infra VN will add this is for signaling control planes and infrastructure. So I'm adding a pool for the wireless access point. We'll call this 50W VLAN, and from the diagram, VLAN ID was 999. And then IoT VN will add our IoT pool, the 1010 pool. We'll call this IoT VLAN shorthand, VLAN 10. Traffic type is data. And again, default SGT in this case, I'll give it a BMS default SGT, again, just in case ICE has not assigned an SGT to the endpoint as it connects in. We'll go ahead and provision this into Fabric. Now, before I submit this change, I'll just show you, I have the two endpoints here. So this is our IoT device, and this is our corporate device. There's a couple of things happening here. The IoT device has internet access. It has access to its IoT device at the east site. So these two devices are the west site, the site we are migrating. And it also has access to the corporate device, which is at the same site. So it's the right-hand one. As I said before, both SVIs are in GRT, so there's no segmentation at the moment. On the right-hand side, our corporate device, internet access, access to the corporate wireless device at the east site, and again, left-right access between these two devices. So I will submit this change. And then I need to go to my existing distribution switch here. And basically, I've got VLAN 10, 20, and 999. So I'll get rid of those on the existing distribution switch. And what we'll see, obviously, is that these devices will now lose connectivity to remote site and internet because they've got no default gateway. So if we hop back into DNA Center, we can see that provisioning to the fabric in a box has concluded. So we can go ahead and just put some trunk ports in that device to bring it up. So if we go to west side, we have our fabric in a box with wireless LAN controller. And if I go to port assignments, port 7 and port 8 connect down to those gray traditional edge switches that haven't been converted yet. Oops, missed a step there. Need to assign trunk role to those two ports. Update, deploy. And what should happen now is basically if we go back to the diagram, these ports 7 and 8 are being converted into trunks. So those VLANs these endpoints are in have been moved from the traditional distribution switch over to the fabric in a box. So if we go back to our devices here, we'll start to see some messages like destination unreachable. So these are coming obviously from the SVIs, .1 and .1. And the reason there's no destinations reachable right now is because we haven't connected this border to anything else. So the last step here is to add a handoff. As I mentioned before, in this demonstration, we're going to focus on SD-Access as a transit. So I will add that to the border. The SD-Access is a reasonably simple construct. It's just some control planes. So I add SD-Access transit and deploy. And what should happen now is the DNA center, if we go back to the diagram, should set up the necessary signaling between this new border, transit control planes, this right-hand side is already connected to SD-Access Transit, so the signaling set up there. The same process was followed, obviously, the right-hand side, we attach a transit to borders. So if we hop back to our endpoints, hopefully in a moment, as we can see, there's been a successful deployment from DNA Center. We should start to see some traffic flowing. So our Windows PC can now reach the internet. It can also reach Corp VN at east side. This here is interesting. This is a Windows nuance that I can't work out. So it claims it can still reach this IoT device on the left-hand side. I don't quite understand what they're doing under the hood, but in essence, I just need to break out and restart. And now we can see that that macro segmentation is working. So IoT device can't contact Windows device and vice versa at the same site, proving that obviously we've got VNs at the site. This extension from west to east obviously proves that the VNs are being transported from one side to the other. And the last thing I'll do now is put in a basic microsegmentation policy to prove SGT extension and SGT policy enforcement.
Oh, a couple questions.
Go for it.
So there's a whole bunch of steps to go through here to do this provisioning. Is there an API that's fully featured that you can automate, like that you can basically create an orchestration workflow from spinning up a container to or bring up a host or whatever to then plumbing it all the way through, giving it whatever access it needs, applying the security policies, and then decommissioning it when you're done?
Yeah, that exactly right. So I am working with a few customers that basically have an orchestration engine outside of DNA Center that they don't want to touch DNA Center at all. They want to build their own automated workflows and push that configuration into DNA Center APIs. So the answer is yes, there is APIs. In all honesty, there's probably a few gaps in the APIs right now. So there's some things you may want to do that might not be possible, but there's also a big focus on making those APIs fully featured. So you might find if you try to do this whole exercise, there might be one or two misses, but we are aware of it.
Okay, so what I'm hearing is there are people that have a strong desire to do an an orchestration
Absolutely.
workflow, and they're currently working on that with this.
Yeah, I'm working with
exist.
one. Spot on. Yeah, I'm working with one customer that is deploying 5,000 devices globally, and they've actually built a workflow outside of DNA Center to deploy sites to reserve IP addresses, define serial numbers, device roles, and they don't want to touch DNA Center at all. They can't quite get there yet, but we are working with them to make sure that's possible.
Okay.
So you're right, there is definitely.
Second question is, are those customers using NSO to do any of the work on this? Is there any integration with NSO?
There is no formal public integration with NSO, and frankly speaking, I can't claim to be an expert on how NSO works. Coincidentally, I do know this customer is actually using that behind the scenes, but the specific details I honestly couldn't share with you. It's outside of my wheelhouse.
I guess my question was really, is there anything that would preclude that from working? And it sounds like the answer to that is no.
Yeah, I'm not aware of anything, but yeah, sorry, I can't claim to be an expert either.
Good enough. Thank you.
Thank you, sir. So we'll just put in this last bit of policy here. So what I've got is this BMS device. We've decided that BMS devices should not be talking to each other. Perhaps they're just communicating with a server in a data center outside Fabric. So in this case, this BMS device, we're going to block it from talking to the one at the east side. So if we look at our group-based policy in DNA Center, we have source BMS, destination BMS. So I can just change this policy to a deny for those two SGTs, save, and deploy. And what we'll see here in a second is that end-to-end connectivity has been implemented. So the group-based policy is working, and obviously SGTs are being transported between Fabric sites. Okay, and the last thing that we'll check briefly, maybe as a stretch target, is whether the AP has joined the wireless LAN controller, which it has. Now, this AP will show up in DNA Center eventually as a Fabric component, but basically there's a slight lag between it registering to the WLC and actually being picked up in inventory and provision. So we don't want to wait for that. So this is just the shortcut to prove that the access point has joined the wireless LAN controller. And then I know we're pretty much over time. So the last step obviously would be to replace those edge nodes with Fabric edges. We don't have time for that right now. There is an established process to do that. They can be done one at a time or not at all if the customer doesn't want to.